Now, finding probabilities of events in a continuous sample space boils down to finding the area under the probability density curve, or the distribution of that continuous random variable. Now, in this case, we're talking about the normal distribution. The normal distribution with center, that is the mean mu, and standard deviation sigma. Now, suppose the curve looks like this. The mean is in the center, let's say. We're trying to find the probability that x, the random variable, lies between a and b. Then what we do is we find the area under the curve between a and b, and once we find the area equals probability, and that would be the answer to the question, what's the probability that x lies between or within the range of values a to b. So finding probabilities boils down to finding areas under the curve. Now let's look at the standard normal distribution. Now, any normal distribution can be converted to the standard normal distribution by changing the scale of the measurements on the x-axis. So if we take 1 unit to be equal to 1 standard deviation, no matter what the normal distribution looks like, whether it's tall and narrow or it's broad and flat, everything can be converted to what is called the standard normal distribution. And this is called standardizing the units. So if x is the measurement in a regular normal distribution, once it is standardized, which means once the scale is changed, then the variable in the standard normal distribution is denoted by z. So x is changed to its z value by converting by changing the scale on the x-axis. So every normal distribution can be converted to the standard normal distribution by using this formula. So if we have an x value in, let's say, a regular normal distribution, and we have an x value in the regular normal distribution where mu is the center and sigma is the standard deviation, how do we standardize it? Which means, how do we find its equivalent value in the standard normal distribution, which has center 0 and standard deviation 1? So that's what a standard normal distribution is. A standard normal distribution has center 0 and standard deviation 1. So the units have to be standardized and converted to their z values, which is finding their locations on the standard normal distribution. So z is equal to take the x value, subtract mu from it, and divide the value by sigma. And this is called standardizing, that is, changing the scale of a regular normal distribution so it becomes then the standard normal distribution. So what we have discussed so far is that a regular normal distribution, no matter what it looks like, broad and flat, tall and thin, the variable is called x. It's a normal distribution with some center mu or mean mu and standard deviation sigma. It can be converted to what is called a standard normal distribution, which has center 0 and standard deviation equal to 1. Where if every x value is converted to its corresponding z value using the formula, z equals x minus mu, you take the x value, subtract mu from it, and divide by sigma, then what we're doing is standardizing the normal distribution. Now, the reason why we do this is because the standard normal distribution, we can find the area under the curve of the standard normal distribution using a table that is given in the textbook. It's called table and it's table B to be precise. That's table B from your textbook, and that gives us the areas under the standard normal distribution. So once we take the regular normal distribution, convert it to its standard form, then we can find the areas using table B. Why do we need to know the areas? We need to know the areas because that is how we figure out the probabilities of events in a continuous sample space. So if we need to find the probability that x lies between a and b in a regular normal distribution, we convert a and b to its standardized form, which is its z values, using the formula z equals x minus mu over sigma, and then we use the standard normal probability table B to figure out the probabilities, which is really the areas under the curve.